Yeah, yeah, so that's 7 log x.
But why not 7x log x?
The 7 gets pulled out as a multiplication. It's like it escapes the integration.
So it's only then when it's additive. It's like 7 plus
additive, yeah. I think of the multiplication, it's like pulling a constant out of the brackets. You know, you take it out of the loop, so to speak. Right. Continuing. Maybe you can wait for the end of the next one then. So next now. Previously we were just looking at integration. And in what we had in the last lesson, we called those integration problems indefinite. Because the C is something that you have to figure out that you don't know. But there is a type of integration where you don't care about the C called definite. So let me just give you the definition here. So for definite integration, you notice what's a little bit different is you have these two numbers which are called limits. Now, what the meaning here is, basically you have to put in the two values into your answer. So let's suppose your function integrates to capital X, we'll call it, capital F. We still have to put in what's called these limits, the lower limit and the upper limit. So that's equal to FB minus FA. Now because you have the minus there, it actually doesn't matter about the C. Let me show you. So suppose I ask you to do 1 to 2 of x dx. That will equal x squared over 2. Now let's just include the c for a moment, plus c. 1 to 2. So if you put in 2, you'll get 4 over 2, which is 2. And if you put in 1, you'll get 1 over 2. But you notice how the c's cancel. So in fact, there's absolutely no need to bother putting the c's in. The final answer is 1.5. Let's do another example here. So suppose I ask you to integrate... Where's my pen gone? There you go. Come on. Come back. There you go. I ask you to integrate something like 1 over x from 1 to 3 dx. So what does 1 over x become? Log x. 1 to 3, which becomes log 3 minus log 1. Now what's log 1? 0. So the answer is just log 3, like that. Okay. Now there's a small problem that can arise. So we've done a couple of examples. So there's one example. There's another example. Let me do another example again. Number 3. I want you to do this one for me. Minus 1 to 3, 1 over x. It's very similar. See what happens here. You can't, there's a problem. Because you'll get log x 3 minus 1, which is log 3 minus log minus 1, and then you realize you have your error. But I could have known that at the beginning. Because not only do we have definite and indefinite integration, we also have something called proper and improper. Example 1 and 2 are proper. Number 3 is improper, meaning it has no answer. How can you tell this at the beginning? Not necessarily, because if I go back to this example here, would there have been any problem if I put a minus 1 here?
But you know it's
a minus 1 in the denominator?
Yeah, but watch this now. Suppose I ask you to integrate minus 1 to minus 1 over 2, 1 over x dx. Is this a problem? No. No. Because this becomes log x minus 1 to minus 2, which becomes log minus 2 minus log minus 1. Now, can you have log minus 2, log minus 1? No. But what's the second rule of logs? This is equal to log minus 2 over minus 1. What's minus 1? Minus 2 over minus 1? 2. So it's equal to log 2.
But if you put the number directly, you still can get it down.
True, but if you simplify it, you can. And that's, by the way, Young Peng, that does happen in the exam. I've seen them do that before.
The same thing we did here.
Yeah.
Why can't we do it in the first one and make it minus 1 over?
Yeah, so in the first one, all you can do is change this into log 3 over log minus 1, which is log minus 3. Yeah, that has made nothing better. Right?
It's just not solvable. Like that.
So anyway, how can we know if we have a proper or improper situation? Because if the situation is improper, then there's no point in solving it because there's no answer. And the both negative can be okay, as we can see here.
One positive, one negative.
No, stop guessing. I'll tell you now, because I don't think anybody can see. So, how can we know if it's proper or improper? Well, this is how we can tell. So what you do is you look at your integration and you look at what you want to integrate. So in the first case, you want to integrate x. And then you ask yourself, if I begin at 1 and increase to 2, will I hit any problems in the function x? No. X can take the value of 1, can't it? It can take the value of 2, can't it? And it can take all values from 1 to 2. Yeah? Now, let's go here. 1 over x. If I begin at 1 and increase to 3, will I hit any problems? No. So this is also proper. 1 over x. If I start at minus 1 and increase to 3, will I hit any problems?
Yeah, 0.
Yeah, I'll hit 0. This is improper. It has no integration. Don't bother solving. Now, this is interesting. So here, if I start at minus 1 and increase to minus 2, I don't pass 0.
Yeah.
So apparently this is proper and should have an integration, which it does. So there's a quick check you can do at the beginning to check if it's proper or improper. And so you can know before you begin if it's worth trying to solve. So what about this one? If I say integrate from minus 1 to 1 ex, is that proper or improper? Proper. It has an integration. What about if I said minus 1 to minus 2 root x?
Can't have a negative inside it.
Improper. I hit a problem immediately at the beginning. It's improper. Okay. So improper and proper just means, are you integrating over a region that's allowed for the function in question? Now, this is something it's a fine point that you don't have to worry about in the exam. They don't ask the student, is the situation proper or improper? But it is a useful thing to know, because in the exam I've seen them do this. Now please listen carefully. Listen carefully. I've seen them give you this question in the exam before. This one I just did. Okay? And some students would stop here thinking, well, there's nothing more I can do because I have a situation that's impossible. Because when I type this in on the calculator, I have no answer. If that happens, you need to say to yourself, so that means my problem was improper. Let me check. And when you examine, you realize it was not improper, it was actually proper. I should be able to continue. And so if you think about it, you can use a rule of log to continue. So the reason I discuss proper and improper is because I want to give you a little tool to let you know if your integration is going right or wrong. So here you might be thinking it's going wrong, and so I have to stop. But if you examine the original problem, you see that there should be no reason to stop. You should be able to proceed to an answer. So this is why we're discussing proper, improper. But all the rules from the last lesson apply to this lesson, just with the addition of the limits. Okay? So again, it's a small lesson. We'll say until 12 o'clock, and then we'll start the third lesson. So, the time for this discussion was at we're finishing this one up at the 10-minute mark only. Oh, just before we do that, there's an interesting integration I want to do. Can I scroll down?
10 minutes.
Right.
Something is a video on its own anyway.
Yeah, it is, yeah, so it'll be easy to find.
Yeah.
Integrate. Oh, come on, pen. Whoa, that's a super integration. Integration 2 power x dx. Shall we put limits in? No limits. We'll just keep it like this. Okay. Did I give you any rules for this one? No. But you can do it, because it's possible to simplify this into a form that has a rule. So have a look at your rules. Which rule do you think I can try and work this into? How can I manipulate this? The second one? X squared type of rule. No. Not a log 1.
2x plus 1.
You've seen this before in a previous lesson. So what you can, exponential. You can rewrite this into an exponential form. Watch, I'll remind you. 1 over log, that's a new one. No, not this one. Watch, just watch. So you could change this into e log 2 x dx. Because remember, e and log cancels, and you're just left with 2 power x. You saw this on...
E and X?
This is the rule we're aiming for, yeah. I'll just, for those who want to know where this is coming from, it was question... Where did I put it? Was it on? It was on page 52, question 5. 52.5 was where we learned how to do this. If you want a bit of revision, page 52, question 5. Anyways, now that I have this, I can think about it like this. E, and this is like a number, this is like the n, e log 2x dx. Now, which rule do I need here? The enx. So what's the rule here? It's still this over log 2. Oh, is this what you were getting at, Amjad? Yeah, okay.
2.
Yeah, you need to be more confident when you speak. Yeah. No, I wouldn't say that, would I? Yeah. Okay. I apologize. I didn't realize you were saying this.
Over log 2x?
No, because enx is over the n, not the nx.
2x over log
2. 2x or 2 power x?
2x.
Oh, Amjad, 2 power x. Yeah. You could have really put me in my place and impressed me there, but maybe next time. Okay, so here what happens is the e and the log cancel, so you're just left with 2 power x. It's up in a power. So you can write the answer as 2 power x over log 2 plus c. I've seen this in the exam, but it really only comes up in the semester 2 exam, not in the semester 1 exam. I've never seen it in semester 1 exam, only in semester 2. Yeah. Okay, so what I want you to try until 12, let's see. In question 1, I just want you to do ABF. 1ABF. In number 2, I'd like you to do ABF. Oh, funny, that's the same. Number 3. In which one?
First.
I got a better idea. You could do it in both. There now. Problem solved. Tree. In tree, just do X and Z. And then lastly, in 4, A and B. Okay. Try these for a few minutes, please.
So we didn't do a four-fact equation. Find the limits. Find the limits.
Oh no, I did that on purpose because I think you can figure it out.
Yeah.
I have a lot of faith in
Oh,
you.
yeah, I get it.
You see,
Because they
my
say-
faith was not misplaced.
They say
Mo, I believe in you. Even when you don't, I do.
Motivation.
That's it, yeah. Just grab a pen off you, young pen. Great, thanks. Or pencil, whatever. Mahmoud, I have, and Gafar, I have, and Amjad, I have, and Zara, I have, yeah. Mo, I have, Daniel, yeah. Sebi, Sabrina, I have. You're in HS2, aren't you? HS1, Sabrina? Yeah. Elfrida? Yeah. Aria? Kitty? Where are you gone? Oh, there you are. Young Peng? Amna? Oh, yes, I do. And Mariam, I do. Where's... Did she step out? Okay. There you go. Yeah.
Am I allowed to take out a common X?
No, only constants can be pulled out.
Because there's a plus C and that doesn't make sense.
Just before I answer, I'm going to close this. Can you write these down? I'm going to close it. A common X. Oh, you mean in the answer or the question?
In the after I integrate,
You can after you integrate, yeah.
like here, from the second line to the third line.
You can, but I mean in the exam they don't expect you to. Just leave the X in.